Okay, we're on example 3. Example 3 is going to be a little bit different because instead of rotating around the x-axis, we're going to be rotating around the line y equals 1. So let's go ahead and graph these. The first one, x squared plus 3. It's a parabola opening up from x equals 1 to x equals 3. Around the line y equals 1, which will be this line right here. So as you can see, when we're looking at this region and rotating around this axis, the radius or the heights are no longer the function value because we're missing this part right here. So what we need to do is we need to think about it, and it's going to be different each time, but this guy right here is actually going to be x cubed plus, x squared plus 3, but then we're always going to subtract this distance of 1, or in other words, x squared plus 2. So that is going to be the radius of our rotation. So the volume works the same way. We still go pi r squared, because we're still finding all these circles. It's just a different radius. And my endpoints I wrote as 1 to 3. So we're going from 1 to 3. All right, I'm going to multiply all that out. I'm going to get x to the 4th plus 4x squared plus 4. Okay, that's going to be a pretty straightforward integral. X to the 5th over 5 plus 4x cubed over 3 plus 4x from 1 to 3. All right, I'm going to get some pretty messy fractions here. So I'm probably going to use a calculator. 3 to the 5th is 243 divided by 5 plus 4 times 3 cubed divided by 3 is 36 plus 4 times 3 is 12 minus, when we plug in the 1 I get 1/5 plus 4/3 plus 4. Again, I'm going to use the calculator. This is 96.6. This is 64/15 or 4.26 repeating. And then when I take those, combine them, I end up with an answer of 92 1/3 cubic units. So again, the only difference between this example and the previous examples was that the radius changes. All right, let's try example 4. Looks like it's going to be very similar. Negative x squared plus 3. So again, up 3 opens down. I'm going to go ahead and write that in the pink. We're going from 0 to 2. I think 2 is going to cross. Let's see, when I plug in a 2, I get negative 4 plus 3, which is negative 1. So it's actually going to be down here at negative 1. And that's actually going to be where, so I'm taking this and I'm rotating it around that line. Okay, so in this case, we got to figure out what this radiuses are going to be. So this part of the radius from there to the x-intercept is just the equation, negative x squared plus 3. And this part here is always going to be a 1. Again, we're looking at distance, so it's always going to be positive. So the total radius is always going to be negative x squared plus 4. So that's what we're going to use as our radius. So our volume is going to be pi times, and we're going from 0 to 2 of that negative x squared plus 4 squared dx. So I'm going to multiply that out. I'm going to get x to the 4th minus 8x squared plus 16. X to the 5th over 5 minus 8x cubed over 3 plus 16x from 0 to 2. This one's not going to be as messy. When I plug in a 2, I get 32 fifths minus 8 times 8 is 64 thirds plus 32. Something I realize I missed now in the previous example was a pi. Forgot to multiply that out, so I'll go back and fix that. Minus, and then pi times, and when I plug in a 0 to all those, I get 0. Alright, so I'm going to use the calculator again to figure out these fractions, so I'm not wasting time. 32 fifths minus 64 thirds plus 32 is 256 pi over 15. Again, cubic units. Alright, so let me go back really quick to example 3. This should be 92 1/3 pi. There should be a pi there, a pi there, a pi there, a pi there. So don't forget the pi from the formula pi r squared.